Hello students, in this module I will be talking about the post-transcriptional modification of hnRNA. Look, listen and learn. So let us see what is post-transcriptional modification of hnRNA. Remember, this happens exclusively in the eukaryotes, and also remember it happens within the nucleus. Is that okay? Now, let us show you a DNA which is ready to get transcribed. So obviously you'll find the transcription bubble. Is that okay? Now, after transcription, it is going to basically form what? It is going to basically form the hnRNA. Yes, this structure formed here from 5' to 3' direction. You can see looks like a hybrid, right? Because it has got dark and light areas, and this is called as the hnRNA. Is that okay? Nice. Now, moving on. If you look at this hnRNA, it has certain areas that are dark shaded and certain areas that are light shaded. Now, these dark areas are called as exons. Now, remember, exons are also called as coding regions because these regions will actually code for the amino acids in the protein. Is that okay? Now, in between the exons, you see the light regions, and the light regions are called as introns. Is that okay? Now, they're called as introns because they are non-coding regions. Non-coding because they will not code for any amino acid in the protein. Is that okay? And therefore, you require post-transcriptional modification of this hnRNA. Let us see how it happens. Okay, I'm showing you the same hnRNA, right? And I'm indicating the same exons and introns and how they are placed alternately on the same hnRNA. Now, the processing of this hnRNA involves 3 basic steps. And the 3 steps are, number 1, splicing. Number 2, 5' capping. And number 3 is called as 3' tailing. Let us see what goes on during splicing, capping, and tailing of the hnRNA. Let us first understand the process called as splicing. Let me show the same hnRNA again with alternating exons and introns. Is that okay? Now, they are the exons and the introns, right? I've just labeled. There you go. Now, what exactly is splicing? Now, the splicing basically involves 2 steps. Step number 1 is removal of introns. So let us go ahead and remove the introns. There you go. The introns just disappeared. Now we have 3 exons. What do? We have to join these 3 exons. So the next step is joining of the exons. Let's go ahead and join them, right? So when I join them, what really goes on is the 3 exons now form one big exon. But that hnRNA top there was a big molecule, but because the introns were removed and exons were joined, it becomes a much smaller hnRNA molecule. Is that okay? We still call it as hnRNA. Now, let us see what goes on in the next step, which is called as 5' capping. So what I brought here is the same RNA which is now spliced because the introns have been removed. Now remember, this hnRNA or this precursor of mRNA has that end out there called as the 5' end. At the 5' end, what gets added basically is an unusual base, and this unusual base is called as 7-methyl guanosine triphosphate. Let us add this on that 5' end. You see there? You just added the unusual base called as MGPPP, which is short for 7-methyl guanosine triphosphate. And this base is called as the cap. So we just added a cap of MGPPP on the 5' end. Why would we do so? We did this because it will regulate the nuclear export of mRNA, and it will also promote translation of this mRNA on the ribosome. Is that okay? That is the purpose of 5' capping. Now the next step involved basically is called as 3' tailing. So let us bring back this hnRNA which has been spliced as well as capped. Is that okay? Now I'm going to perform tailing here. So on the 3' end, I'm going to basically attach these few molecules which show only adenine nucleotides. So I refer to them as adenylate residues. Let me go ahead and add this on the 3' end. On the 3' end, about 100 to 150 adenylate residues get added. Is that okay? And this end is now referred to as the poly-A tail. Is that okay? Because there are several A's attached to the end on the 3' end. Is that okay? Cool. Now why would you do the tailing? Remember, the tailing protects the mRNA molecule from enzymatic degradation in the cytoplasm. Now, this structure up here is what you will finally call as mRNA. So, no more hnRNA, no more pre-mRNA. This is your mRNA, which has undergone the process of splicing. It has undergone the process of capping on the 5' end. It has gone the process of tailing on the 3' end. And such mRNA, which has undergone splicing, capping, and tailing, is called as mature mRNA. Is that okay? Right? Now this brings us to the end of the module where I talked about the post-transcriptional modification of hnRNA. In the next module, I'll be introducing the process of translation. Till then, thank you and take care.